Today, we want to talk about many functions, one graph. I want to specifically go through how I come up with a function to assign as a problem, the things that I look for. Before, I've been giving you a graph or an equation and asking you to find the vertical shift, the amplitude, the period, and the horizontal shift, which also includes the start, which tells you to use plus or minus, sine or cosine. So today we just kind of want to go backwards through that process. I want to start with a generic sinusoidal graph, and I want to figure out how to fill in the points, and that'll give us a better idea about how to solve the problems that we have this week. So first thing, as far as drawing, this is not something that I'm asking a lot of. Mostly because we're talking by computers, and if we've got that tool available to us, then why do we want to be drawing things by hand? But let's suppose that we're drawing things by hand. Notice that between my important points, the bottom, the middle going up, the top, the middle going down, the bottom, and so on, I marked off on my grid. I have 3 spaces. So I put the bottom, and I went 3 spaces over to the middle going up. Then it's 3 spaces to the top, 3 spaces to the middle going down, and so on. What we're doing is we're going around the circle in 30-degree increments. We're going around the circle in 30-degree increments. So that's pro tip for drawing nice sinusoids number 1. Plot things out in 30-degree increments. The reason that we want to do this is sine of 30 is a half. So the reason that we want to do this is that if I mark off the middle and then down 2 spots on the grid is the bottom and up 2 is at the top, I know that sine of 30 degrees is a half. And so all my 30-degree reference angles, so 30 degrees before the middle, 30 degrees after the middle, is where we're going to hit a half. So 1/2 at the 30-degree reference angles. So that gets us, instead of just drawing straight lines up and down, that gets us the bend a little bit more. So that's pro tip number 1. Plot things out in increments of 30 degrees, because sine of 30 is a half. And then the points that are closest, the 30 degrees on either side of your middle, that's where your 1/2 will be. That's where vertically will be at 1/2. So those are Leach's pro tips for drawing nice sinusoids. Measure out your horizontal axis in 30-degree increments, and then 30 degrees before and after the middle is where you'll hit the 1/2. Here's the middle going down, but 30 degrees before and 30 degrees after, we're halfway to the top and the bottom. That gets you a nice bend in your sinusoid. All right. So let's talk about how I come up with graphs for you to find the equations of. The first thing I do is I look for the vertical information. I decide where the middle is going to be, and I decide what the amplitude is going to be to figure out where the top and the bottom are going to be. So I start off with where the middle is going to be, where the middle is going to be, where this horizontal line where the middle is going to be. So let's suppose that the middle is going to be at -2. We just have to pick something. So I'm just going to say the middle is at -2. Also in my mind, I'm thinking I've used -2 already, so I want to use different numbers. Now, next, I'm going to figure out what the amplitude should be. And the amplitude is going to be the distance from middle to the top and the middle to the bottom. So the next thing I do is decide on an amplitude. I've used -2. Let's say that the amplitude is going to be 6. I'm just picking stuff. Once I figure out the amplitude, I just go above and below the middle 6 units. So that tells me that the top is going to be -2 plus 6 to put us at 4, and -2 minus 6 will put us at -8. So now all my important points have their y coordinates filled in. All my y coordinates at the top will be 4. All my y coordinates at the bottom will be -8. All my y coordinates in the middle will be at -2. So the coordinates down here, I haven't figured out the x's yet, but the y coordinate will be -8. I haven't figured out my x coordinates yet, but my y coordinate will be -8. At the top, haven't figured out my x, but my y coordinate is 4. Haven't figured out the x, but the y coordinate is 4. And along the middle, haven't figured out, let's see, this week. Haven't figured out the x, but the y coordinate's -2. Same thing here. Y coordinate's -2. Same thing here. So I've got all my vertical information sorted out. The next thing is I decide on the where I want things to start. I usually like having 2. So I think of there being 4 points: the bottom, the middle going up, the top, and the middle going down. I like to split these and decide where the 0 is going to be, and then just pick a starting value. So if I say I want to start here at the top, in my mind, I'm starting off at -1. So in this, right now in my mind, I've used -1. So that's what I consider to be the start. We can use any one of these points as a starting point for plus and minus cosine or plus or minus sine. But in my mind, in writing this problem, I said, I'm going to start at -1. Now I just need to figure out what 1/4 of the period is. So next I'm going to figure out 1/4 of the period. So down here between any 2 points, the top and the middle going down, for example, this is going to be 1/4 of the period. I just want to figure out that step. So 1/4 of the period, we just need to pick a value. How about, let's see, I've got how about 5? Let's say 1/4 of the period is equal to 5. So my starting value is at -1. I'm just going to add 5 as we move through the x's. So -1 plus 5 is going to be 4. 4 plus 5 is 9. 9 plus 5 is 14. 14 and 5 is 19. If I go backwards the other way, -1 minus 5 is -6. -6 minus 5 is -11. So this is where I chose to be the start.
So just to make sure I understand, all of these choices are arbitrary, correct?
Correct. I had to pick something to be the middle and an amplitude. And I just wanted to make sure that whatever set of points I pick will be able to determine all these numbers.
And the choice of period is also arbitrary?
Also arbitrary. Okay. I like to try to use different numbers. I don't like to have ones and three. Like I wouldn't want to have the middle at 3, the amplitude be 3, the period, 1/4 of the period be 3, and then start at 3. I like to make sure that they're all different. So notice that the 1/4 of the period and what I picked as the starting value, those are arbitrary. I just chose -1. So my vertical axis is going to be over here. So, oh, sorry, I banged into the camera. My vertical axis is going to be here somewhere. I just picked -1 to start, and I said the next x is going to be 5 units away. So -1 plus 5 is 4. 4 plus 5 is 9. 9 plus 5 is 14. Going the other direction, if we're adding 5 going to the right, we're subtracting 5 going to the left. So 14 minus 5 is 9. 9 minus 5 is 4. 4 minus 5 is -1. -1 minus 5 is -6. -6 minus 5 is -11. So now I've got enough information. As long as I'm careful about what 2 points I give you, I just need to give you 2 points, and you can find the equation or multiple equations for this graph. So in one of the problems, if I gave you this top value, and I can give you the bottom value, that gives you twice as much amplitude, so you just have to cut it in half. If I gave you this bottom value and this the value at the bottom and a point in the middle going up, you can figure out the amplitude is 6, and then you'll be able to figure out the middle, and so on. Note that if I gave you a -11, -8, and 9 -8s, that would be enough to figure out horizontal information, but you'd have no way to figure out the vertical information. So next, we just have to pick a pair of points so that you can figure out both pieces of information, or all 4 pieces of information: your vertical shift, your amplitude, your horizontal shift, and the period. Any questions? Let's now take this information and write some equations. If, for example, I'm writing the problem for the discussion, I've made these decisions, I figured out where all these points are going to be, I figured out which 2 points I'm going to label on the graph for you. Now I need to produce the graph in some program so I can have a picture of it. So I picked as my start -1, 4. But a lot of things, the rest of the stuff doesn't change. My middle is at -2. My amplitude based on this information is going to be 6. 1/4 of the period is equal to 5. So that tells me the period is 4 times 5, or 20. 20 is not the number that we put into our equation. So if the period is 20, then B is 2 pi divided by the period, which is going to be 2 pi over 20 in this case. And we can simplify that, pi over 10. So pi over 10 is the value that's going to go into our equation. Now I just need to pick a start. Anything that starts at the top is going to be a positive cosine. So here we'll use positive cosine. At 19.4, we'll use positive cosine. At -11, -8, these are at the bottom, so I'd use a negative cosine if I chose those points as the start. At the points where we have at the middle going up, that's going to be a positive sine. Middle going up is a positive sine. The middle going down is a negative sine. The middle going down would be a negative sine. Those are the 5 pieces that we need: the middle, the amplitude, the period, some horizontal shift, and which sign, which function, and what sign, positive or negative. So if we imagine -1, 4 to be where we're starting, the constant term is always going to be the middle. So we start off with -2. And then we adjust the -2. The amplitude is equal to 6. That's what gets multiplied by, if we're starting off at the top, positive cosine. So it's going to be a positive cosine. Then we open up parentheses for the argument of cosine. The coefficient of theta is going to be pi over 10. That's going to be our multiplication before the trig function. So it's going to be our change our period. And then we do theta minus. And then we pick our horizontal shift. So we're starting off at -1. So it's theta minus a -1. So here is an equation that will give us the graph. The thing we want to remember is that the horizontal shift is always going to be theta minus then whatever the number is. So write theta minus, and if it happens to be negative, change it to +1. So let's jump over to our graphing calculator to make sure everything went well. So if we look at the graphing calculator, plug in y equals -2 plus 6 times the cosine of pi over 10. And then we have theta, I'm going to use x plus 1. Looks like we're zoomed in a little bit. And let's find the highest point, -1, 4. That's what we wanted. The next low point, oh, that's not going to be where the middle is. 9, -8 is the bottom, and then this bottom over here should be -11, -8. The next top is 19 over 4. Now notice at this point here, 2.980, that's not the middle. That's not going to be the 4, -2 that I was looking for. If I go in and tell Desmos where the middle is supposed to be, I say, hey, Desmos, the middle is at y equals -2. So now we can find out there's the middle going up at -6, -2, the middle going down 4, -2, the middle going up at 14, -2, the middle going down at 24, 2. Notice that our bottom points in the horizontal direction are 20 units apart. From -11 plus 20 is 9. -6 plus 20 is 14. That's one cycle. 4 plus 20 is 24. That's one cycle. And then -1 plus 20 is 19. That's one cycle. Any questions? So it looks like this equation is going to give us the graph that we wanted. Now, this was not one graph, one function, one graph. This is many functions, one graph. And so this is going to be the follow-up question to write an equation for the graph that you see. Once I've got all these points labeled, we can write an equation with any of them at the start, as a start. So for example, let's suppose that I'm reading -6, -2 as the start. The middle is still -2. That's not going to change. The amplitude is still 6. The coefficient of theta is still going to be pi over 10. The form of the horizontal shift will always be in parentheses, theta minus whatever the horizontal shift is. The last thing I need to do is pick some point to call the start. So if I choose to start here at -6, -2, -6, -2 is at the middle going up. So I'm going to use positive sign. And my horizontal shift is -6. So theta minus a -6. Now, if I jump over to Desmos to make sure that this is going to give us the equation that we want, I'm going to plug y, I'm going to type y equals -2 plus 6 times the sine of pi over 10 times theta plus 6, which really is theta minus a -6. Notice that the green graph is just sitting right on top of the red graph. So they're all in the same spot. Oh, I can't decide. There we go. So now we have two equations for this one graph. This is because the shape is always the same, and it goes on forever in both directions. We're just choosing different points to be the start, to be what we're deciding for a start, for where the horizontal shift should be. Let's try some more. Let's go over to this point where we have the middle going down at 4, -2. Certain things don't change. The middle is still at -2. I'm going to have a plus or a minus, but my amplitude is definitely going to be 6. I'm going to have a sine or a cosine, but in the parentheses, we'll have the coefficient of theta will be pi over 10. That's what's giving us that period of 20. Oops. And this gets multiplied by theta, but theta with a horizontal shift. So I'll put theta minus. Finally, when I go to, since I'm starting at 4, -2, I'm at the middle going down. So I'm going to use negative sign. And my horizontal shift will be the x coordinate of 4. So I'll write theta minus 4. Or, because I got plus cosine, plus sine, minus sine, I have to do all 4. Look at all the stuff that doesn't change. I haven't even picked a start, but I know my middle is at -2. I'm going to have a plus or a minus, but my amplitude is going to be 6. I'm going to have a trig function, sine or cosine, but in parentheses, the coefficient of theta is still going to be pi over 10. And this gets multiplied by theta minus the horizontal shift. Now I just have to pick any point to start. Let's suppose that we're starting off at 9, -8. So since the 9, -8 is at the bottom, that means we're using negative cosine. And then the x coordinate is a 9, so our horizontal shift is theta minus 9. Any questions? All right. So one of the things that's really important to remember is that when you're in a math class, you're not doing things that you're actually going to be doing in your future career as fill in the blank, whatever it happens to be. That's not the point of this exercise. The point is to take the information that we're given and figure out how to reform it into an equation. Take some visual information, a graph, and form it into an equation. We want this connection between the graph and the equation. We want to see a graph like this and imagine an equation with sines and cosines. It's funny that we were talking about the matrix earlier before class started. In the matrix, there's those scenes where they're sitting in front of the computer monitor and the computer monitor is not rendering an image. It's just giving a bunch of symbols. So the computer monitor is not rendering this image of this sine wave going along. It's just giving you a bunch of symbols. And yet everybody looks at the screen, sees these symbols, and is clearly thinking about this picture. the symbols are connected to the picture. Here's just those green monitors where all the weird characters are flowing down. But the human is taking that picture and translating it in their mind. So that's what they see, even though they're not looking at it directly. Any questions?
I have one quick question.
Uh-huh. You're not coming through on audio.
I'm just. Say again?
You weren't coming through on audio. You're cutting out a lot.
Oh, apologies. Can you hear me now?
I can hear you now.
Okay, perfect. I was confused on how did you choose cosine, sine for the equations?
So the choice of cosine versus sine and positive versus negative. So we have 4 choices, right? Cosine, sine, positive, and negative. That depends on whether we start at the where we're considering our starting points, wherever we're getting our horizontal shift. Is that horizontal shift at the bottom, the top, the middle going up, or the middle going down? If we choose as our horizontal shift a point at the bottom, that means minus cosine. If we choose for our horizontal shift a point at the top, that means we're going to use positive cosine. If we choose as our horizontal shift a point where we're at the middle going up, we're going to use positive sine. And if we choose as our horizontal shift the middle going down, we're going to use negative sine. So positive and negative are tied to, and sine and
depending where you start.
What's that?
They depend on where you start on the graph.
They depend on where you start.
Okay.
So if we start at the top, then we use positive cosine. If we start at the bottom, then we use negative cosine. If we start at the middle going up, then we're going to use positive sine. And if we start at the middle going down, then we're going to use negative sine.
Another quick question. This entire Zoom meeting is recorded. I have a question on where they're like, where's the video? Where can you find the video later
on my channel on YouTube. The link to the video is in the discussion section. There'll be a link called on Canvas. In the discussion section, there'll be a discussion called Week 7 Notes and Videos. You click on that, and then in there will be links.
Okay, perfect. Thank you.
So one of the reasons that it makes sense that the top and bottom are at plus cosine and negative cosine is the fact that cosine of 0 is 1 and cosine of 180 is negative 1. So if you want this to connect to something that we've done before, cosine of 0 is positive 1 and cosine of 180 is negative 1. So that's why the cosines starting off with the +1 and the -1, the top and the bottom. +1 corresponds to the top, -1 corresponds to the bottom. For the middle going up, sine of 0 is 0, and it's the y coordinate, so sine of 0 is then increasing. Sine of 0 is 0, but increasing. Sine of 180 is also 0, but then it's going to decrease after that. So it's all connected. Sine of 0 is 0 and increasing. Sine of 180 is 0 and decreasing. So it's those zeros and 180s. That x-axis means something. So that connects it to things that we're supposed to be remembering. It also helps us remember those things. Any questions? So all I'm doing when I'm coming up with these problems, it's nothing fancy. I'm just drawing a generic sinusoidal graph. I'm deciding where the middle should be. I'm deciding on an amplitude, and my vertical stuff is sorted out. I just put the middle at -2. I go up 6 and then down 6. The tops are all the same. The middles are all the same. The bottoms are all the same. That's my vertical information. 2 things. Next, I need to sort out my horizontal information. So I just pick somewhere to start. That's like picking the middle at -2. I just pick somewhere to start. And then I figure out what each step is going to be. Each 1/4 period step is going to be. Then I just figure out what the rest of the points are. And then I just start coming up with equations. Any questions? It's a super fun game. I know next coming up Friday, you're going to be wanting to hang out with your friends and say, hey, what are we doing? And you're going to be like, oh, dude, let's come up with some sinusoidal functions. And they're going to be like, oh, heck yeah, that sounds awesome. We'll be right over. And then no one ever shows up. But the joke's on them. That just means I get to eat all the pizza. I'm just kidding. I've never thrown a sinusoidal function party that anyone attended. I'm just kidding. I've never attempted that. It was a solving oblique triangles party, and everybody showed up. And I didn't get any pizza because of it. I'm just kidding. I always get pizza. Any questions, comments, or snide remarks? My favorite pizza is the nearest one. So in my current location, there's a Signores where that used to be a round table, switched to Signores. I was a little disappointed because I kind of like round table, even though it's kind of like cheap pizza. But then there's also Toto's in San Bruno. That's also awesome pizza. So. But ultimately, favorite pizza is just the nearest one. Any other questions? I also favor Toto's because the extra large is like stupidly large. It's like a stupid amount of pizza. And it's like the size of pizza where you're like, oh, I'm just going to save some of this for tomorrow. Most of this I'll have for tomorrow. And then you end up eating most of it and feeling awful. It's like, oh man, I'm never going to eat pizza again. Then you realize that there's cold pizza the next day. And you're like, oh, until today. And then your doctor's like, oh, how come you're dying? I'm like, oh, I don't know. I'm not sure. I'm eating right. And then the doctor's like, oh, you ate an entire pizza, didn't you? I'm like, well, yeah. My wife was on a business trip. What do you think I'm going to do? I'm going to eat a whole pizza. That's just how it works. Here's another thing that we want to get out of these graphs. So these periodic graphs, they just keep doing this up and down thing forever. One of the places that we're going to go, one of the places that we need to go in every algebra course is to start solving equations. Trig functions are going to show up in equations. And those equations are going to have lots of solutions. So another thing that we're going to have to think about oops. So if I've got a sinusoidal function, and I want to say, let's say a sine of x is equal to some constant. Remember that if we think in terms of the graphs, the solutions to an equation are going to be the points of intersection. So just here, we can see 4 solutions. But these are just the ones that we can see. This graph is going to keep going in both directions, and the sinusoidal graph is going to keep going in both directions. So we can see there are going to be infinitely many solutions. Now, this is not always the case that we'll get infinitely many solutions. It could be that if we have a line that goes at an angle, so instead of a horizontal line, we have a line going up at an angle. Here's a line that only intersects the sinusoidal graph one time. But I could draw another line. Here's a line that's going to intersect the graph 3 times for 3 solutions. So what we want to start to put together when we start solving trigonometric equations is that trig functions, sine and cosine in particular, trigonometric functions are periodic. And so we're just going to have these copies that go on forever. So if we try to find the intersection of a trig function and a horizontal line, we're going to have infinitely many solutions. Or the opposite of that. If I try to intersect this trig function with a line way down here, since the sinusoidal graph has a top, a middle, and a bottom, if I draw a horizontal line below the bottom, there's going to be no intersections. So the corresponding equation will have no solutions. Any questions? Fortunately for our heroes, we only need to concern ourselves with what's going on in one cycle, because graphs of sine and cosine functions are periodic. So whatever happens between 0 and 2 pi just happens again between 2 pi and 4 pi. So if I take all my solutions and just add one period to it, or add a multiple of the period, then we'll have all the solutions that we need. So we really need to only look at what happens in one cycle. So yeah, there'll be many solutions, but we only need to concern ourselves with what's happening in one cycle, because everything else is just copies of that cycle, shifted horizontally. Any questions? Here's another thing that we want to observe from this. Notice that I've taken these 4 functions, even though we could have written many more. Here are 4 functions that represent the same graph. Many functions, one graph. And 2 of these functions are cosine and 2 of them are sine. So another thing that we notice is that the trig functions are related to each other. Trig functions are related. So it's going to be very important for us to understand, to know what those relationships are and understand those relationships. And then looking at those relationships and knowing why they make sense, so that it doesn't just become a list of things that we have to memorize. So we describe the relationships between trig functions with what we call trig identities. An identity is just an equation that's always true. And we've seen some of these already, like cosine squared x plus sine squared x equals 1. That's a trig identity expressing a relationship between sine and cosine. That's a nice general one that's very useful. And we know where it comes from. It makes sense because the equation for a circle is x squared plus y squared equals 1. X on a unit circle, the x coordinate of any point is the cosine of theta. and the y coordinate at any point is the sine of theta. So since x squared plus y squared equals 1, if x is cosine and y is sine, cosine squared plus sine squared equals 1. So we see how they're connected, and so the relationship makes sense. Here are some other trig identities that we can have. Any one of these equations is equal to another one. That's a very specific identity, but it's an identity nonetheless.
Would you be able to then solve for theta? And what would it mean to solve for theta?
In an identity, we wouldn't have to solve for theta, because if we say something is an identity, that's true for all values of theta. So ultimately, if we solve for theta in an identity, we'll just find out that theta is equal to theta.
Okay.
So that's the difference between, and that's this particular kind of equation that is an identity. So an identity is an equation that's just always true. So theoretically, we could take an identity and just break it all the way down to theta equals theta. I guess that's the mathematical equivalent of it is what it is. So cool in math, so weird when people say it in meetings. Any questions? All right, that's the game today. I wanted you to see how to come up with your own sinusoidal function, and then how to write many equations that represent that graph that you just produced. You want to make sure that all your points are the right places apart, are the right distance apart. Choose a middle and an amplitude. Choose a starting point and a quarter of a period to fill out all the points. Then think about what information could you give to someone, what 2 points could you give to someone that they could use to figure out the rest. And that's what those the four discussions are. Any questions? All right, that's going to do it for today. Everybody have a good couple of days. I'll see you on Thursday, and thanks for playing.